everyone, myself Dr. Ranjith Kumar Gatla, working as an associate professor in the Department of Electrical and Electronics Engineering. So in today's class, we are going to continue the discussion on network topology or the graph theory. In the previous class, we have already discussed the various basic terminologies that we are going to use in this network topology or the graph theory. So which means how the electrical circuit can be converted into the graph, okay, or the electrical circuit, how the graph can be drawn from the electrical circuit. So, and again in the graph, okay, so what is mean by the node and what is mean by the branch, okay, so how we can represent the elements as a node or branch. Then after that, again there are various types of graphs that we are discussed, which is the connected, unconnected, and what is the directed and undirected graphs. So these also we have discussed, and also we discussed about the subgraphs, right? So what is called as a subgraphs, and also various types of subgraphs also we have discussed, right? So which is tree and co-tree, okay. So what are the branches in the tree are called, and what are the branches in the co-tree are called, okay. So the branches in the tree are called twigs, okay, and the branches in the co-tree are called links, or we can also call as a chords. These things, these all are we have discussed in the previous class, okay. And the oriented and non-oriented graph also we have discussed, and we have also discussed how the network can be converted into the graph, right? Okay. So based on all these basic terminologies which are associated with the graph theory or the network topology, so now we are going to the exact topic, okay. So how we can write the incidence matrix or the basic tie set matrix or the basic cut set matrix, okay. So actually before that, what is the use of writing these incidence matrix or basic tie set matrix and basic cut set matrix from the given graph or from for the given network, okay. So here this is also a kind of network reduction technique. So as we discussed in the earlier classes, the various network reduction techniques. So the purpose of the network reduction techniques is to find the response across any element. The response is nothing but either it may be the current flowing through the element, or it may be the voltage across the element, right? So for this purpose, we have discussed various network reduction techniques, including the network theorems. So here these graph theory, in that graph theory, the incidence matrix and basic tie set matrix and cut set matrix are also a kind of network reduction techniques, okay. So how, the incident matrix and basic tie set and cut set matrix will help to reduce the network or find the response across any element. So these things also we have discussed in the previous class, like what is mean by the incidence matrix and what is basic tie set matrix and cut set matrix, okay. So of course here the incidence matrix is represented with a letter A, and basic tie set matrix is represented with B, and the basic cut set matrix is represented with C, okay. So here the zeros and ones, of course in these matrix we will be having only ones and zeros, okay. Of course the ones having the positive and negative signs. So which means usually in these matrices we take the node as a common point, okay. So if there is any link to the particular branch, okay, from that node, then we will make it as a 1, okay. Otherwise we will make it as a 0. And if that branch direction is, okay, as the reference direction, then we will consider as a +1. And if it is opposite to our reference direction, then we will be considered as a -1. These are the basic conditions, okay, are the common conditions that we are going to follow to write these incidence matrix and basic tie set matrix and the cut set matrix. So first we are going to discuss about the incident matrix, right? So as we discussed here, this incidence matrix is represented with a letter A, and the order of the incidence matrix is n cross B. So as we know what is n and what is B, so here n represents the number of nodes in a graph, okay, and B is the number of branches in a particular graph. So here, which means here we are going to write the incident matrix for this given electrical circuit. So first what we should do, so we should convert this electrical circuit into the graph. Then after that we have to indicate the number of nodes and branches in that particular graph. Okay. Then from that particular graph, okay, so after that we have to draw the oriented graph, because which means here every branch should have the what is the direction. Okay, the direction represents the current direction. Okay, which means from which node to which node the current will flow. Okay, so then the incidence matrix will be n cross b, which means here n is the number of rows and b is the number of columns. Okay, so number of nodes and number of what is that branches. So number of nodes represents the number of rows, and the number of branches represents the number of columns, right? So here first we are going to convert this given electrical network into the graph. Okay, so for that, as we know here, we should just of course the graph is also having the same nodes which the given electrical circuit consisting of. There are here 3 nodes are there, and another one is the 4th node. So let us indicate the same nodes 1, 2, 3 and 4. Then see, okay, so what are the branches which are connected in between the nodes? So let us take 1 and 2. In between 1 and 2 there is one branch, right? And then in between let us start with 1. Okay, so then 1, 2, 3 is also there. There is another branch 1, 2, 3, which is the resistance R4. Then 1 to 4 is also there. There is another branch with the voltage source, which is V1, 1 to 4. This is with respect to 1. Then from 2 to 3, there is a branch which is having the resistance R2. And then 2 to 4 is also, there is a branch which is having the resistance R3. So 2 to 4. Then again 2 to 1, of course, already we have drawn. Then coming to the 3. So 3 to 2, that already we have drawn, and 3 to 1, that is R4, already we have drawn. But 3 to 1 and 3 to 4, there is another voltage source V2, which is 3 to 4. Okay, then 4 to 1, 4 to 2, 4 to 3 already is having. So this is how we can convert the given electrical circuit into the graph. Then this is unoriented graph, which means there are no directions indicated in these branches. Okay, now we should indicate the branches. Of course, let us consider here, this is the direction, because the same like our loop directions we can consider. Okay, so this way and this way. Okay, and here this is this way, and here it is this way, and here it is this way, right? So how many number of branches are there? Let us consider here R1 is, let us consider A, and R2 is B, and R3 is C, and R4 is D. Okay, and this one E and F, right? So which means here how many nodes are there, which means n is equal to how many nodes? 4 nodes are there. So which means this is equal to the rows in a matrix. Then how many branches are there? A, 1, 2, 3, 4, 5, 6 branches are there. So here B is equal to 6. So which means columns are 6 are there. Then now we are going to form a matrix. Now we are going to form a matrix. And before that, here the same way, here the n is equal to 4 and b is equal to 6, right? Okay, so now we are going to form a matrix here. Let us indicate the matrix is with A, right? So here how many, here the nodes are, because n cross b, so rows into columns, so rows are number of nodes. How many nodes are there? 4 nodes are there. So let us consider here n1, n2, n3 and n4, right? Then how many branches are there? A, which means these are the columns, A, B, C, D, E and F. This is the matrix, right? Okay, so let me draw here clearly. So here A, B, C, D, E, F, right? Okay, so now we are going to write the the elements in this matrix. Okay, so as we discussed, all these incidence matrix or tie set matrix, cut set matrix, these matrix having the elements are either 1 or zeros. Okay, and also of course one, there is a sign also, whether it is a positive sign or negative sign. Okay, so here you can see here the graph which we are indicated. Okay, so first node 1 to A. So here first start with let us start with the first row. Okay, let us fill the first row. So N1, which means here the node 1. So from the node 1, how many branches are there? A is there. Okay, so which means here 1. If there is a, the branch which is connected to that node, then we should indicate A. So then next B branch, there is no connection between the branch B and this node 1. So that's why it is 0. Right? And before that here, of course, there is a connection to the branch A and the node 1. Then here the positive, and whether it is a plus 1 or the minus 1. So here the sign represents whether the direction of the current flowing through the branch is towards the node or away from the node. If it is towards the node, then it is positive sign, and if it is away from the node, then it is a negative sign. But here, as you can see here, the current flowing through the branch A is away from the node. Okay, so that's why here it is minus 1. Right? Then branch B. Of course, there is no connection between 1 and branch B. So that's why it is 0. Then C. Of course, C, there is a connection between the C. Okay, so the C is connected to the node 1, and the direction of the C is also towards the node 1. So that's why here it is plus 1. Then D. Of course, there is no connection between the branch D and the node 1. So it is 0. Right? And then E. Of course, there is no connection between E and node 1. So 0. And then F. Of course, F is there, but F is also, the direction flowing through the F is away from the node 1. So that's why it is again minus 1. Then coming to the N2. This is node 2. Okay. So then when coming to the node 2, again, what are the branches connected to the node 2? First, let us come with A. A, of course, A is connected to node 2, and the direction of the A is towards the node 2. So that's why plus 1. And B is also connected, and the direction of the B is also towards the node 2. So that's why here plus 1. And C. Of course, there is no connection between the branch C and node 2. So it is 0. And then D. Where is D? Yeah, D. Here D is there, and D is here. The branch D is connected to node 2, but the direction is away from the node 2, so which is minus 1. And next branch E. E is, there is no connection between E and the node 2, so 0. And F, where is F? Yes, there is no connection between 2 and F, again it is 0. Right? Then similarly N3. Okay. So when coming to the node 3 here, this is node 3 now. So A, there is no connection between the branch A and node 3, so 0. And B, of course, there is a connection between branch B and node 3, but the direction of the current flowing through this branch is away from the node 3, so which means here minus 1. And then C, of course, there is no connection between C and node 3, fine, so 0. And D, and there is no connection between the node 3 and D, then 0. And E, of course, there is a connection between node 3 and E, and the direction of the current flowing through the node E is towards the node 3. So that's why here plus 1. And then F. Of course, F, there is a connection between the branch F and node 3. And again, the current flowing through the branch F is towards the node 3. So plus 1. Then similarly, N4. Now, with respect to N4. So here, this is the N4. And what are the branches which are connected to this N4? Of course, A, there is no connection between A and 4, 0. And B, there is no connection between B and 4, 0. And C, of course, there is a connection between 4 and C, but the direction is away from the node 4. So this is minus 1. And then D, of course, there is no, there is a connection between D and 4. And again, the direction is towards the node 4. So plus 1. And then E, of course, there is a connection between E and node 4. and the direction is away from the 4, so that's why -1. And then F, of course, there is no connection between the node 4, the branch F and node 4, so that's why it is 0. So this is how we should write the incidence matrix, right? So see, the same way that we have written. So here, of course, for the node 1, what are the branches which are connected? A, that's why A, and C, here C, and F, and F. All other elements are 0. And again, coming to the direction, okay, of course here, the A and F are away from the node 1, so that's why A and F are having the minus sign, and C is towards the node 1, so that's why plus sign, right? Then similarly, with N2, node 2, okay, what are the connections? A, B, and D. So A, B, and D. Others are zeros. But here A and B are the same towards the node 2, but D is away from the node 2, so that's why D is having the negative sign, but A and B are having the positive sign, right? Similarly here, when coming to the node 3, what are the branches? F, B, E. So here you can see here B, E, F. Of course here the direction of the B is away from the node 3, so that's why here the direction of the B, which is -1, and the remaining are +1. Similarly with respect to node 4, okay, so C, D, and E. So C, D, E. But here other than D, okay, these C and E are away from the node 4, so that's why these are having the minus sign, and this is having the positive sign. So this is how we can write the incidence matrix, right? So here very simple here. So first we need to convert the given electrical circuit into the graph, and we have to indicate the directions of the branches in that graph according to the the loop directions in the network. Okay, then after that, as we know, simply this is N cross B. So here the number of nodes represents the number of rows, and number of branches represents the number of columns. And then you can check whether, okay, so from the first node, what are the branches which are connected to the node 1? Okay, then we will assign the 1 and other branches 0. And if the direction is towards the node 1, then the +1, and if the direction is away from the node 1, then -1. Very simple, right? This is about the incidence matrix. Then we will go for next one is the basic tie-set matrix. Okay, so here the basic tie-set matrix is represented with letter B, because the incidence matrix is A, and the basic tie-set matrix is represented with the letter B. And here the order of the incidence matrix will be L into B. So here L is the number of links. Okay, so here when you will get the number of links, the links are nothing but the branches of the core tree, okay, are the links, right? So that's why we gone through the basic terminologies, okay, before going to discuss these things. Because now if you know how to identify the tree, or what is mean by the link, or what is mean by the twig, okay, then only you will get understand these concepts, right? Fine. So here the links are nothing but the branches of the core tree. So then what is mean by the core tree? Okay, so that we should know. Then here, of course, here same like in the incidence matrix. Okay, so the number of columns are same like incidence matrix, the number of branches, but here the number of rows are the number of links, right? So in this case also, again, because we have considered for our simple understanding, we have considered the same network which we are considered in the previous section. Okay, so here also first we should convert this same network into the graph. This is the graph, the same graph. Okay, and that we should indicate the directions of the currents in each branch, the same like in the before case that we have indicated. Now of course the same circuit, so that's why here the number of nodes are 4 and the number of branches are 6. Of course here the branches, which means the number of columns, are same. But what about the number of links? So which means we should draw the code tree. Okay. So if you want to draw the code tree, okay, then first we should draw the tree. Of course, for a given circuit, I mean, as we know, there is there is no such condition like we will having only one tree. Okay, there are a number of trees, either maybe 3, 4, 5. That is based on the network or based on the graph. So let us consider a one tree. Okay, there is no what is that condition like we should consider only this tree, because there are, let us draw the other tree for this particular what is that graph, because as we know what is mean by tree. Okay, so the tree must have all the nodes, okay, present in the given graph, but there should be a no closed loop. Okay, so that is mean by the tree. So which means here, of course, as you can see here, this code tree, this tree is having all the nodes 1, 2, 3, 4, and here the solid lines, as you can see, these are the branches of the tree, which is called as a twigs. So because there is no closed loop. Okay, and another tree let us draw here. Of course, for the tree also it should having all the nodes 1, 2, 3, 4, 1, 2, 3, 4. Okay, so 1, 2, 3. This is also a kind of tree. We can consider this tree is also not an issue. Okay, fine. Or let us draw another tree. 1, 2, 3, 4. 1, 2, 3, 4. So here 1, 2, and 3. This is also a tree, because all the nodes it consisting and there is no closed loop. Okay, so that's how you can consider any tree, but here just I have considered this particular tree. Okay, this particular tree. So which means then how many links are there for this particular tree? Okay, 1, 2, 3, because this is the code tree. Okay, so this dotted line is the code tree, because here if you draw the branch A, then it will form a closed loop. Okay, and if you draw a branch B, then it is form a closed loop, and if you draw a what is that branch F, then it is a closed loop. Okay, so that is what the code tree. So which means then how many links are there? 1, 2, 3 links are there. So which means now the basic tie set matrix will be having 3 cross 6 matrix, because here the number of rows represents the links and number of branches, the number of columns represents the branches. Then how to form this matrix, right? Okay, so let us consider this. Then first draw how many code trees are there. Okay, for this particular tree. So the first code tree is with the branch A. Okay, or branch F. Okay, so if you are just draw the branch F, then it will become a code tree, because it is because of this link, or because of this branch. Okay, so it is forming a loop. So that's why this is called as a code tree, or this is called as a what is that link. The branch of the code tree is called as a link. Then the second one, of course, in this case, if you just include the branch A, again it is forming a closed loop. Okay, so that's why this is also called as a code tree, and the branch of that code tree is called as a link. So the first link and the second link. Then the third one, let us consider. Okay, so the third one is with B. So of course, if you just include the what is that branch B, then it is also forming a closed loop. So that's why this is also kind of a code tree. Okay, and the branch of this code tree is also called as a link. Then how many links are there? 1, 2, 3 links are there, or the 3 code trees are there, right? So that's why the number of rows. Okay, so in other words, we can also consider the number of rows, or which is L, is equal to the number of code trees, or the number of links for that code trees. Okay, right? So now we are going to draw a matrix. Okay, so here also the same way the matrix. Okay, so because already here is there, but let me just write the matrix. Of course, let us consider here it is B, right? And of course here the same, the links are number of rows L1, L2 and L3, let us consider. And again the columns are similar, A, B, C, D, E, F. Okay, so these are the what is that columns. So first link L1. Okay, so what is the link L1? Here it is F. Okay, so whether is there any connection between these F and this A. Okay, only what are the connection between F and what is that other branches. Okay, one is C, another one is E, right? Okay, one is C, another one is E, and another one, of course, F is already there. Okay, so now as you can see, whether the direction of the these what is that the current flowing through this link is same as like the other branches, okay, which are connected to that link. Okay, so what are the other branches? Of course, here it is a C and E, but here the direction of the C is same like as the F. Okay, but the direction of the E is opposite to that F, right? So which means here first let me give you when we should consider zeros and when we should consider ones. Okay, it is not like in the previous case, it is different case, because before it was with respect to the node, but here it is with respect to the links, because here the columns are, sorry, the rows are links. So that's why first let us consider with the link 1, which is F. Okay, so here what are the other branches which are connected to this link? The C and E. So which means only these what is that columns having the what is that one, others are zeros. So that's why here you can see, of course, there is no A, 0, and B is also not connected, 0, and C, of course, C is there, but let us consider, okay, 1, and D, it is not connected, 0, okay, and E, of course, E is there, let us consider 1, and F is there, let us consider 1. Then when we should indicate the sign as a plus or minus? Okay, if the direction of the current flowing through the link, I mean the twigs, is same as the link, then we will make it as a positive sign, and if it is opposite, then we will make it as a negative sign. Okay, which means here the loop is forming with these 3 branches only. So that's why we should consider only these 3 branches, right? Of course, here the direction of these loop is same as like this link direction. So if you see this direction, okay, but the direction of these loop current direction, and the current flowing through this branch E is opposite direction. So that's why here we should indicate this -1. And then this is then coming to this C. Okay, C is same like as the loop current direction, okay, which is taken from the link direction. So both are same direction. So that's why here C is 1. Of course, F is again same, 1. Then coming to the second code tree or the second link. Okay, so here again we should say same, take the direction like this with respect to the link direction, right? Okay, so here A, D, C. So which means here A is there, so 1, B is 0, and C is 1, and D is 1, and E is 0, and F 0. Right? Because only 3 branches are there for this particular loop. Okay, so that's why 3 ones. And again, of course, A, because this is the reference direction, +1, and C is again same direction, so +1, and D is also again same direction, so +1. So here all are the same direction with that loop direction, so that's why all are the positive signs. Then coming to the L3, this one. Okay, so here the direction is again with respect to the B, so this is the direction. Okay, so in this case, as you can see, here the direction B, okay, of course B, D, E, all others are 0, so A is 0, and B, yes, of course B 1, and C is also 0, and D, yes, of course 1, and E is also 1, and F is 0. Then when coming to the direction, of course these A and this loop direction, this B and loop direction is same, so +1, and this D and loop direction is same and +1, and E and this loop direction is same and the +1. So this is how the the basic tie set matrix, right? So as you can see here, so we should consider only the branches to form a loop, okay, and we should indicate the direction of the loop direction as same as the link direction, okay. Then here the the branches in the loop, we usually make it as a 1, And if the branch current and the loop current direction is same, then we will indicate +1. And if it is opposite, then we will indicate as a -1. This is about the basic, to write the basic tie-set matrix from the given electrical network. So I hope everybody get understood. So how we can write the basic tie-set matrix from the given electrical network. Then the third one is the basic cut-set matrix. Okay. So here the basic cut-set matrix is represented with the letter C. Okay. And here the order of the incidence matrix, okay, or the order of the, not incidence matrix, the order of the basic cut-set matrix is T into B. So of course, again here B is the number of branches. So you can see, you can observe in the basic, the incidence matrix and basic tie-set matrix and the basic cut-set matrix. In all these matrix, the number of columns represents the number of branches only, right? Okay. So only the number of rows are different, right? Okay. So here T represents the twigs present in the tree. Okay. Before links and here the twigs present in the tree, right? So of course, just now we have discussed how to draw the tree. Okay. So for this given network, first again we should, of course, for our simple understanding purpose, I have considered the same electrical circuit and from that circuit already we have discussed how to convert this graph and how to indicate the directions of the branches in that particular graph, right? So here this is the tree that we have considered, and of course here what are the number of links the number of twigs present in the tree? 1, 2, 3. Okay, then how to form a cut sets? Okay, so here to form a cut sets, okay, so how many twigs are there? So the number of cut sets are formed, right? Here how many twigs are there? Twigs are nothing but the branches of the tree. So the tree is formed with the branches C, D and E. C, D and E. So here the 3 branches are there for this particular tree. So which means here the 3 twigs are there. So twig C, twig D and twig E. So that's how we will get the 3 rows and 6 columns as it is. Then how to form a cut set? Okay. So here we usually, for each twig will form a cut set. So here this is the twig. So in the cut set, okay, in the cut set, it should have only one twig. Okay. Okay. In the basic cut set, it should have only one twig. So of course here you can see, usually the cut set will form at the nodes. So how many nodes are there? 4 nodes are there. Okay. So you may, if you don't know any condition, then we may think like here, there is a possibility of getting the 4 twigs, the 4 cut sets. But here, of course, the cut sets will form at the nodes, but the condition is the cut sets should have only one twig. Okay. So of course, for here, let us see 1. Okay. So how many, branches are there? 1, 2, 3 branches are there. But here, how many twigs? Only one twig is there. So here we can form one cut set. And at node 2, again, only one, twig is there. So we can form a cut set. And of course, here at node 3, again, one twig is there. So we can form a cut set. Then the direction of the cut set is whether it is towards the node or away from the node depends on the direction of the current flowing through the twig. So here for the first cut set, let us consider here it is C1 and here it is C2 and here it is C3. So for the cut set 1 C1, so the direction of the twig which is connected to cut set 1 C1 is towards the node 1. So that's why here the cut set direction is towards node 1. And when coming to the cut set 2, here the twig connected to this cut set is D and the direction of the current in the D is away from the node 2. So that's why here the cut set direction is away from the node 2. And when coming to the the cut set 3 which is connected to node 3, and here the twig which is connected to node 3 is E and the direction of the E is towards node 3. So that's why here this is the direction of the cut set. Okay, so this is how we can indicate the cut sets. So from this now we are going to write. Okay, so as you can see here, because here the C direction is towards 1, so that's why here the C1 is the direction is towards 1, and here the direction is the current flowing through the branch D is away from the node 2, so that's why here this is the way to indicate the cut set direction, and here this is the way to indicate the cut set direction. Then how we can write the matrix? C is equal to, so again here C1, C2, C3, and then A, B, C, D, E, F, right? Okay, so first C1. So as you can see here, A, C and E. So A, C and F, sorry, not E, F. Okay, so which means here for the first cut set, how many branches are there? Okay, so A, C, F. So A, C and F. The remaining are zeros. Then whatever the direction, whether the direction of the current flowing through the branch is same like as the cut set direction or not. If it is same, then +1. If it is opposite, then -1. Right? So here the cut set direction is towards the node 1, and the current flowing through the branch A is away from the node 1. So which means here the direction of the cut set and the direction of the current flowing through the branch A are opposite to each other. So that's why here we should indicate the -1. Then coming to the C. Of course, the direction of the current flowing through the branch C and the cut set direction is both are towards the node 1. So that's why here it is a +1. Then F. So the direction of the current flowing through the F is away from the node 1. But here the cut set direction is towards the node 1. So both are opposite directions. So that's why here it is -1. See, very simple, right? Next, coming to the cut set 2. So what are the branches which are connected to cut set 2? A, B and D. So A, B and D and the remaining are zeros. Then again coming to A, whether the cut set direction and A are same or not, opposite to each other, because here the cut set is away from the node 2, but here A is towards the node 2. So that's why here it is -1. And coming to the B, B is also, it is towards the node 2, but here the cut set direction is away from the node 2. So that's why here -1. Of course, D is same as the cut set direction. So +1. Then coming to the C3. So of course, C3, here this is the cut set 3. B, E, F. So here B, E, F. Remaining are zeros. Then again, whether it is a plus and minus, of course, here E is the same as the cut set direction, so +1. But here B is away from the which means opposite direction to the cut set direction. So that's why here B is -1, and here F is same as like the cut set direction, so +1. So this is how we can draw the basic cut set, or we can write the basic cut set matrix. Okay. So as you can see in all the cases, okay, because in the first case it is with respect to the node. Okay, in the second case, it is with respect to the link. Okay, and third case, it is with respect to the cut set. Right? So, in all the cases, in the first case, if how many branches are connected to that particular node, then in those branches, we will write as a 1, the others 0. In second case, okay, so how many branches are connected to that link are having 1, okay, the remaining branches are 0. And in the third case, how many branches are connected to that particular cut set are 1, the remaining are 0. So this is common point in all the cases. And again, another common point is also, as you can observe, in the first case, okay, so whether the current is towards the node or away from the node. If it is towards the node, then +1, away from the node, -1. In the second case, which is the basic, what is that, tie set, okay. So there, whether the direction of the current is same as like the loop direction or not. If it is same like the loop direction, then +1, and opposite, then -1. Then how to indicate the loop direction, which is same like as the link direction, right? Then cut set. So here, if the direction of the current flowing through the branch is same like the cut set direction, then +1, opposite, -1. Then here, how to indicate the direction of the cut set, which is the same like as the tweak. Because of course here the cut set having only one tweak. So that's why There is no confusion. So the direction of the cut set is same like as the twig. Then opposite means minus 1. Okay, so don't get confused. Here the incidence matrix is with respect to the nodes. So which means here the columns in all the cases are same. So how many branches are there? Then those are the columns. But the rows are, in case of incident matrix, the rows are number of nodes, and in case of basic tie set matrix, the rows are the number of links, and in case of basic cut set matrix, the rows are the number of twigs. Okay, so I hope everybody will get understood about this network topology or the graph theory. Okay, so the next topic we will discuss in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.